Hi, so for my voltmeter project, this is my code. So these are private macros right here that basically serve work setting up the LCD and sending the messages. Some includes right here that help with displaying certain messages and also using Boolean variables. So my private variables right here. These are used to for the UR2 and also for the LCD. These variables right here, these are used to calculate and store the battery voltage and the battery percentage. So the variables that have measurement max, that is the amount or the maximum amount that we will basically get from 0 to uh 4095. So between those numbers, depending on the battery, the maximum number that we're capable of reading uh are these numbers. I had to use um math to get them. They were tricky, but I finally got them. These variables right here, they help in initializing, um, I will call it the sequence that will help in calculating. So three different cases. So 9-volt batteries, 1.5-volt batteries, and 3-volt batteries. So to make sure that we are reading the proper type of battery, I created these variables. And better explanation and see why the why of this will make much more sense in a little bit. These two variables work for to make sure or to help in the system reset, which was one of the last command I did in the video. It resets the whole system, so the user can start from zero without the need of um, flashing the board or just pressing the reset button in the board. And that there's a command which the user can use. So these are function prototypes. These ones are the normal ones because I'm using the U as RT, ADC, GPIO, timers, and the I2C. And then, oh, sorry, didn't mean to do that. So these are my functions. So I have two functions to this one to display the voltage and one to display the charge. And I have three functions to help me calculate the voltage. Three functions because as you saw up here, I have three different specific values. So in order to calculate voltage for three different types of batteries, I needed three different types of specific numbers that will help me calculating these. So to calculate voltage and percentage, I needed one function for each case, so I can calculate percentage and the voltage. So declaring the LC clear. So these are the functions that help setting up the LCD screen. So I did not write these functions. These functions came from lab 9, if I'm not mistaken. I just copy and paste them. So these two functions that I have created right here, these functions help me display this like the actual implementation of the function. So I created a character array of 16 uh, pages, and then here I print the voltage to one floating point number or floating number, and then I am displaying the first row of the LCD, and then this writes the message. The same here. I am displaying the charge, but now I'm displaying the second row of the LCD. So 9V percentage, 9V voltage. These are the functions that calculate the percentage and the voltage, of course. So the first function that is called is the percentage. So I get the analog measurement, then I divide it by the maximum that we will be able to read, or an approximate maximum. It's mostly an approximate number. It's going to get divided by that, and then we're going to multiply it by 100 so we can get a nice looking percentage number, right? And then it returns the battery percentage. So the voltage takes in this battery percentage, multiplies it by 9 because we're using a 9-volt battery, and then it divides it by 100 so we can get the actual battery voltage. So it's the same with 1.5 volt batteries. We get the analog measurement, we divide it by its estimated maximum, and then multiply by 100 to get a nice looking percentage. Then return it, and then we feed that return value from this function into this function, so we can start calculating what is the voltage. We multiply with 1.5 because it's a 1.5 volt battery, and then we divide by 100 so we can get a appropriate voltage number, you know. So it's the same with a 3-volt battery, same process. So here we have a function that helps calculate the percentage. So if by any chance I get a misreading of a negative number, so if it's less than 0, so the battery percentage will be always set to 0. And then we're going to return that. If the battery percentage is anything over 100, we're going to make it to be 100 and then return that value. If it's within a appropriate values, then if it's between 0 and 100, then it would just return it without a problem. So here we initialize our system, my GPIO, the ADC, the timers, the I2C, the USRT to start the timers, and then start the pull-up resistors right there. They initialize the LCD and the black light, and then also, you know, start the URT. So this is where the fun starts. So we start by reading our values. Since it's inside the while loop, my microprocessor will continuously read values from it's going to convert the analog values constantly. So if I do not send a message through a PuTTY, none of these are going to be activated. None of these. So this is one of the fun stuff. So right now we're going to use the URT2. So when we're writing this part, handling the writing, so as long as we haven't, you know, done any of these, then that means that the message is able to get. I didn't write that part of the function. That came from, I think, lab 9, well, not lab 10, sorry. So now this is the part that I built. So first message, if we get a view underscore B9, then we're gonna turn on the yellow LED, set the 9 battery to true, and then we'll send back this message to the computer. So when it's true, right here, this is when the fun part starts. So this will be active because remember, the while loop is constantly running, and then it's going to enter here, and then it's going to get the analog measurement, return the percentage, get the percentage here, um, send the percentage here, make sure that it's within the correct bounds, then return it, and then return to feed it into the voltage function, and then uh, display it here. But the percentage is displayed here, voltage is displayed here, and then this makes sure that if I have activated the 1, 5, or 3 volt battery sequences, this makes sure before displaying any values that the screen is turned off and that these other two sequences are turned off. This is just making sure that the only thing that we're displaying is the battery voltage and percentage for a 9-volt battery. So it's the same process overall for each type of battery. We do the measurements, make sure that the other sequences are turned off, and then display. Same, make our calculations, make sure that these are turned off, then display. So then if I send a reset messages, let me show you back down here. So this is my message, then turn on the green LED right here, and then turn off the other LEDs, and then send back the message, set it to true, and the message is view underscore 120. This is a message for 3-volt batteries, set it to true, turn on the blue LED, turn the other ones off because sometimes we don't really know which one is on or off, like previously, and then send back the message. Now, if the user wants to reset, all other sequences are turned off. Just from start, turned off, reset all or deactivate all the LEDs, then reset system, set it to true, and then send back the message. And then we go back up here. Sorry about that. This is going to be true, and it's going to clear the LCD screen, and then it's going to reset system equals to false, meaning that we have already successfully reset the system, and we're not going to get in here again. And since everything is turned off, nothing else is going to get activated unless a message is sent through PUT. So I hope my explanation was good enough. I really had a lot of fun doing this project. I really loved it. And well, let me know if you have any questions. Thank you so much.